This is Bob Capetta from the College of the Florida Keys, and this lesson is on solving system of equations by graphing. In particular, these will be linear equations, so each equation will give us a line. So here's our first example. We want to determine whether or not this system has a solution of 4, 1. So is 4, 1 on this point, and is 4, 1 on that point? If so, it is a solution, probably the solution to the system. So using x equals 4 and y equals 1, we're going to plug those into the equations to see if we get a true statement. So my first equation is 2x minus 3y equals 5. Plug 4 in for x, plug 1 in for y. So 2 times 4 minus 3 times 1. Is that 5? 2 times 4 is 8. 8 minus 3 is indeed 5. So that gives us a true statement. So plugging 4, 1 into the first equation results in a true statement, which tells us that 4, 1 is a point included on that line. Is 4, 1 a point included on the second line? Which, of course, x is 4, y is 1. Plugging it into x plus 2y equals 6. Plug 4 in for x, plug 1 in for y, and we get 4 plus 2 times 1 is 6. 4 plus 2 is 6. Indeed, 6 is 6, so that is true. The point 4, 1 is included on the first line. The point 4, 1 is included on the second line. Therefore, 4, 1 is a solution to that system of equations. Most of the time with two lines, there is one solution. There's rare circumstances where you could have more than one, and we'll discuss that in class. Let's take a look at one more case like that. Determine whether or not the point 2, negative 3 is the solution to this system. 4x plus y equals 5, and 3x minus 2y equals 10. So x is 2, y is negative 3. Plugging in the first equation, 4x plus y equals 5. 4 times 2 plus negative 3. That's 8 plus negative 3, or 8 minus 3, which is indeed 5. So 5 equals 5, which tells me 2, negative 3 is on the first line. But that's not enough. To be a solution to the system, the point has to be included on both lines. So let's try the second. Again, x is 2, y is negative 3. Plugging into 3x minus 2y, is that equal to 10? 3 times 2 minus 2 times negative 3. 3 times 2 is 6. Negative 2 times negative 3 is positive 6. So we get 6 plus 6 is 10. I don't think so. 12 is not equal to 10. So 2, negative 3 is not on the second line. It's on the first, but that's not enough. So in that case, it is not a solution to the system of equations. So there is a solution to that system of equations, but it is not 2, negative 3. So let's talk about one process to find the solution to a system of linear equations. So here we go. I have y equals 1/4 x minus 3 and y equals negative 3/2 x plus 4. My goal is to graph both of those lines and then find the point of intersection. So I was very kind. Both of these are given in slope-intercept form. Y equals mx plus b, y equals mx plus b. So graphing will be fairly easy. Here's our first line. Y equals 1/4 x minus 3. So the slope m is 1/4. Y equals mx plus b. The y-intercept is negative 3. So we'll start with the y-intercept on the y-axis at negative 3. Here it is. My slope is 1/4. Rise 1, run 4. 1, 2, 3, 4. So here's 2 points. We can continue that process. Rise 1, run 4, 1, 2, 3, 4. There's another point. Down 1, back 4, 1, 2, 3, 4. And we get a few more points and we connect them up and it looks like that. So that's the graph of y equals 1/4 x minus 3. But I am looking for the point that's common to both lines. So what is my second line? My second line is y equals negative 3/2 x plus 4. The y-intercept is 4 up here. Slope is negative 3/2. Rise negative 3, 1, 2, 3, run 2. Rise negative 3, 1, 2, 3, run 2. Rise negative 3, 1, 2, 3, 1, 2, run 2. So there's the first point, y-intercept at 4, and there's rise negative 3, run 2. When we connect those up, this is what we get. The solution to this system will be the point of intersection. What does it appear to be? It appears to be right here with an x of 4 and a y of negative 2. But certainly we should check that. We should plug 4, -2 into each of our equations to make sure that both are satisfied. So remember, our equations were y equals 1/4 x minus 3 and y equals -3/2 x plus 4. So we'll plug it into both to see what happens. So we believe the point of intersection is 4, -2. We're going to do a check. Starting with y is 1/4 x minus 3, plugging in 4 for x, and plugging in -2 for y. Is -2 equal to 1/4 of 4 minus 3? 1/4 of 4 is 1. So does -2 equal 1 minus 3? Does -2 equal -2? That's a check. So it worked in the first equation, but again, that's not enough. We should check both. The second equation, y is -3/2 x plus 4. Let y be -2 and x be 4. -2 is -3/2 of 4 plus 4. Let's talk about -3/2 times 4. 3 times 4 is 12, divided by 2 is 6. A negative times a positive is negative, so that would give us -6. -2 is -6 plus 4. -6 plus 4 is indeed -2. So both checked, therefore we are certain that our point of intersection is 4, -2. What was nice about that question was I gave you both lines in slope-intercept form. That's not the case here. So we want to determine the solution to this system of equations. 2x plus y equals 3 and 3x minus 2y equals 8. So is there a way for us to do this that will give us an answer? Well, it looks like my first strategy is to solve for y by adding -2x to both sides. So now I have y is -2x plus 3. So there's my slope. My slope is -2, or -2 over 1. My y-intercept is 3. So that'll be fairly easy for me to graph. Start at 3, rise -2, run 1. My next example, 3x minus 2y is 8. Let's call that 3x plus -2y equals 8. Add -3x to both sides, and we get -2y is -3x plus 8. Then divide by -2. -2y divided by -2 will be y. -3x divided by -2, negative over a negative is a positive 3/2 x. 8 divided by -2 will be -4. But just to make sure we see that, dividing both sides by -2, left side -2y over -2 is y. -3x over -2 plus 8 over -2. But -3x over -2, negative over a negative is positive 3/2 x. 8 divided by -2 is -4. So now our slope is 3/2, y equals mx plus b. Our slope is 3/2, our y-intercept is -4. Now I need to graph both of those lines and find the point of intersection. So my first case, slope is -2 over 1, y-intercept is 3. Let's graph that line. Y-intercept is 3. From there, rise -2, run 1, rise -2, run 1, rise -2, run 1. So that's what that line looks like. My second line, we have m is 3/2, b is -4. b is -4, rise 3, 1, 2, run 2, rise 3, 1, 2, 3, run 2, 1, 2, boom. It looks like I have a point of intersection. Rise 3, 1, 2, 3, run 2, 1, 2. So we'll take a look at those. So I have this blue dot at the y-intercept, and I have this other blue dot after I rose 3 and ran 2. Connecting those lines, we get a point of intersection here. Where is that point of intersection? It looks like it's x equals 2, y equals -1. Now, we certainly could go through and check that if we were so inclined. So let's go back to the beginning with 2, -1. X is 2, y is -1. 2 times 2 is 4, plus -1 is 3. Check. Works in the first one. 2, -1. 3 times 2 is 6. -2 times -1 is +2. 6 plus +2 is 8. So it does indeed check in both of those equations. So we're certain that that is our point of intersection. So in our last example, we use slope-intercept form to graph, but there's more than one way to graph a line. This time I'm going to graph both lines using intercepts. So y-intercept, which we can get, x-intercept, which we can get as well. How do we do that? We do that by setting values to 0. So we could certainly write this in y equals mx plus b form to get the y-intercept, but I'm going to do something a little different here. The first equation I have is 3x plus 2y equals 6. I want the y-intercept. The y-intercept occurs when x is 0. So I'll plug 0 in for x in that first equation to get the y-intercept. So I get 3 times 0 plus 2 times y equals 6. 0 plus 2y is 6. Dividing by 2, I get y is 3. So when x is 0, y is 3. That is my y-intercept. To get the x-intercept, I will let y be 0 and see what x is. So plugging in 0 here, 3x plus 2 times 0 is 6. Gives me 3x equals 6, dividing both sides by 3, and I get x equals 2. So this time x is 2 and y is 0 is the other point on the line. If I have 2 points on the line, I can graph that line. So let's take a look at a graph. 0, 3 is here. 2, 0 is here. Connect those dots. If you want, you can see the slope, rise -3, run 2. So I could rise -3, run 2 to get an extra point. Up -3, back 2 to get an extra point. And then I go ahead and I connect them all. So that's what the line 3x plus 2y equals 6 looks like when I graph it by using intercepts. But I need to graph both lines, so now I have one line graphed. Let's graph the second line. X minus 2y equals 14. I want to find the y-intercept first, so I'm going to let x be 0. If I let x be 0, then I have 0 minus 2y is -14. That, of course, is 0 plus -2y is -14. Dividing by -2, -14 divided by -2 is +7. So when x is 0, y is 7. That's one of my intercepts. That is my y-intercept. To get the x-intercept, we're going to let y equal 0. Letting y equal 0, I get x minus 2 times 0 is -14. X minus 0 is -14. X is -14. So when y is 0, x is -14. So the x-intercept is -14, 0. So again, I have 2 points. If I have 2 points, I can draw the equation of the line. So here's the 2 points I'm starting with. Where are they? 0, 7 is here. -14 is there. If you want to think about slope, up 7 over 14, up 7 over 14, 7/14 is the same as 1/2. So you could also rise 1, run 2, rise 1, run 2, and do it that way. As you can see, rise 1, run 2, rise 1, run 2, rise 1, run 2. So now I've successfully graphed both lines. Let's put them together and see where they intersect. So here they are, both lines graphed, and they intersect here, or appear to intersect here, which is an x value of -2 and a y value of 6. So that appears to be the point of intersection. Again, if I'm solving by graphing, I like to check. I like to be confident that what I have is indeed contained on both lines. So I want to go ahead and check this. X is -2, y equals 6 is what we think is the point of intersection. So one of our lines was 3x plus 2y equals 6. 3 times -2 plus 2 times 6. Does that equal 6? 3 times -2, -6. 2 times 6 is 12. -6 plus 12 equals 6. So indeed, this point, -2, 6, is contained on the line 3x plus 2y equals 6. The second line I have, or second point I have here is, second line I have based on the point -2, 6 is x minus 2y is -14. So we'll plug -2 in for x and 6 in for y and see what we get. We get -2 minus 2 times 6. Does that equal -14? Make that minus plus negative. So -2 plus -12, or minus 12. -2 plus -12 is indeed -14. So that point, -2, 6, was contained on both lines. Therefore, that point, -2, 6, is indeed a solution to the system of equations. And that will conclude this lesson.